Okay, the Big Bang. Well, the Big Bang theory is basically a theory that the universe started from a tiny point. Everything came from this tiny point and expanded from this tiny point and is still doing it. It started about 13.5 billion years ago that the universe came from this tiny point and has been growing ever since. We believe at that time, when this tiny point started to expand for the first time, space, matter and time were created then. I know it's hard to imagine time being created, but it was created then. Can I point out, even though it's called the Big Bang, there was no noise. It was just simply an expansion of space, reminiscent to an explosion, but with no noise. What's the evidence for this? Well, the evidence for the Big Bang is that we can see the redshift of galaxies, that all the galaxies appear to be moving away from each other, and those that are furthest away are moving away the fastest. Okay. The other evidence we've got for it is something called cosmic microwave background radiation, or CMBR. Now, this is seen all over the universe. If you point a telescope that detects microwaves, every single direction in space that you look, it exists. Okay. Now, these were originally gamma rays, and gamma rays, you probably know, have got a very, very short wavelength, and these were created right at the start when the Big Bang happened, and then since the universe has got so big, the gamma rays, the wavelength, has been stretched and stretched and stretched as the universe has grown. So what were originally gamma rays are now microwaves, and they exist all over the place. They can sync of the whole universe, and it has been mapped. And when we map it, it actually shows us what the early universe looked like. We can see lumpiness in it, so we can see the first ever sort of lumpiness of space by looking at the microwaves. But that's not for this course. Now, the cosmic microwave background radiation can only be explained by the Big Bang theory. There are other theories as to how the universe was created, but none of them can explain the cosmic microwave background radiation as well as the Big Bang can. Other evidence for the existence of the Big Bang, by the way, is that there's a lot more helium in the universe than we would expect. So roughly around a quarter of the universe is helium, and there's no way stars could have produced that much helium in 13 billion years. So what it suggests to us is at some point the universe must have been so hot that fusion was happening all over the universe, and which of course suggests that that supports the Big Bang as well. What's likely to happen as a result of this? Well, we know the universe is getting bigger. Will it keep on getting bigger forever and ever and ever? And that's known as the Big Yawn. Or will it just get out to such a certain point and then begin to fall back? And if it did that, we get something called the Big Crunch. Okay, and that can be shown in a graph like this at time, where it gets bigger or it gets smaller. The most amazing is in the last 15 years, we've actually discovered not only are the galaxies moving away from each other still, but they are actually accelerating. Now, we find this very difficult to explain, and it's at the limit of our knowledge, but hopefully in the next 15-20 years, someone will be able to explain that. But at the moment, it seems likely it's going to keep on getting bigger and bigger and bigger. And that is everything you need to know about the Big Bang.